Predictive shielding is an expansion of Microsoft's autonomous protection stack beyond the reactive paradigm. This is where defenses get truly proactive, anticipating an attacker's next move before they start acting. Predictive shielding leverages the broad suite of Microsoft tools, unifying data to infer attack protection and risk, and then uses those insights to prevent compromise. In this demo, we'll talk through a scenario where predictive shielding provided just-in-time, or JIT, tamper protection. A hands-on keyboard attacker gained access and began operating inside the environment. Attack disruption automatically contained the compromised user, and predictive shielding anticipated the attacker's next steps and hardened the environment. We'll start by playing the attack story to understand the attack progressions and complete the response. The first indication of compromise is an anomalous remote connection from an external IP into a domain controller using a privileged account. Defender identified the attacker trying to create a new privileged account, and within seconds, attack disruption contained the user involved, blocking it from moving laterally in the org. Defender then takes it to the next level. By predicting the attacker's next move, Defender recognizes the pattern and leverages the TI engine to map it to other campaign methods, techniques, and tools used by the threat actor, and uses that knowledge to infer what they're likely to do next. One of the typical next steps used by this actor is rebooting devices into safe mode to disable security controls. Predictive shielding uses that insight to anticipate the next phase of the attack. The threat analytics profile, which was automatically correlated to the incident, reflects that same understanding and logic, providing visibility into the threat actor's overall tradecraft and methods. Here, a new type of alert is generated by Defender, a predictive shielding alert, identified by the predictive shielding tag. If we open the attack surface map, it shows how Defender uses exposure data and the environment's topology to calculate the blast radius. In other words, which devices the attacker can actually reach from here, not just hypothetically. Based on this activity chain and the exposure topology, Defender has determined that devices joined to this domain are at risk of being rebooted into safe mode to disable security controls. Defender has also identified what's likely to happen next and already took actions to outright prevent them. Now let's take a look at what Defender actually applied. The Activities tab shows us the actions taken by disruption, including the new Predictive Shielding hardening controls. In this case, Safe Boot hardening was applied. Now, let's pivot back into the incident to review the impact of that action. In the alert timeline, it shows that the attacker did in fact attempt to reboot devices into safe mode, which was blocked as a direct result of the hardening policy that was proactively deployed. Defender continues tracking the attacker's activity, and predictive shielding engages again, anticipating the attacker's next move. This time, the attacker pivots to the group policy mechanism, attempting to push modified security configurations across the environment to tamper with the security stack another way. Predictive shielding identifies the path the attacker is trying to use and protects the devices within that blast radius by temporarily pausing group policy propagation to those assets. Predictive shielding hardens these mechanisms just in time and only in the context of concrete risk, blocking the attacker's move without disrupting legitimate use. The attacker attempted to use broad tampering techniques to obscure and disable the security stack, clearing the way for widespread impact with no resistance. Predictive shielding had already anticipated that move and hardened the environment ahead of time, so the tampering never landed. Defender remained fully operational, and when the payload was launched, it was blocked immediately, preventing any impact. Pivoting from the summary card, it shows exactly which devices had the hardening policies applied. Now that you know where to expect any temporary changes in device behavior, you can keep your teams aligned. Next, you can dig into the actual block events triggered by Defender's controls. It shows which malicious activities were stopped and on which devices. Defender also shows you exactly which files or configurations were blocked. For example, here is the modified registry configuration the attacker tried to push that was prevented from being applied. With this level of optics, you know precisely what the attacker attempted to change, what was stopped, and where remediation or follow-up validation might be needed. Instead of wondering what the attacker might have touched, you have a clear, actionable map of what was protected and what should be reviewed. This is the kind of visibility that transforms response from reactive guesswork to confident, data-driven action. Microsoft Defender uses predictive shielding as a proactive defense strategy designed to anticipate and mitigate threats before they materialize. Microsoft Security.